Good morning, class. Welcome to the segment length and congruence lecture. This is the second section in our book. The first thing we need to talk about is the ruler postulate. Does anyone have a guess at what that might be? Mr. von Altenstein, what do you think? It means you can use a ruler to measure stuff? Yes, but not entirely. Mr. Hodenstein, the points on a line can be matched one-to-one with real numbers. Those numbers being called the coordinates of the points, and when we subtract those two coordinates, we get what we call the distance between points A and B, also known as the length of AB. Sorry, the length of segment AB. Good, I see you read the book. The ruler postulate applied to this problem right here means that I could match up my ruler or meter stick or whatever measuring device I am using to my segment here. But it doesn't mean I have to match it up with 0 starting at one of the endpoints. I can line it up in some other fashion. For instance, I'm going to start with 20 on point A, and it's going to be somewhere around 60 for point B. So point A is going to be at 20 centimeters. Point B is going to be at 60.5 centimeters. Ruler postulate tells me that if I would put or associate these two numbers using a ruler or a measuring device, that to get the length of that, all I do is subtract the two. So the length of line segment AB, written as such, 2 points next to each other, no comma separation, they're squeezed together, equals, well, it's going to be coordinate 2 minus coordinate 1. It always has to be a positive value. So 60.5 minus 20. In this case, if I would have flipped it around, it would have been 20 minus 60.5, but the absolute value up. So it would be positive still. So in this case, the length of line segment AB is 40.5. And that would be my answer. One thing to note, because I did give units at the top here, I should also include my units down. Example 1. Measure the length of these segments to the nearest centimeter. I drew 3 different segments behind me, and I'll be measuring them shortly. The reason is because of your monitor. These lengths will be different than if I would have just measured them off my computer screen or your computer screen. It will be a different answer for everyone else if you're measuring it off the computer screen. If you are using a ruler, a few things I didn't mention before, but you should be careful. Some of them don't start at the end, so you might have to start a little bit in. This first black line is actually 0 for the millimeters up here, or sorry, the inches. And the same thing down here for the centimeters. 0 is actually not the edge of the ruler. They do this so that way when this gets worn down, it can still be used to measure. But remember, the ruler postulate says I don't have to start at 0. I just have to assign 2 numbers from a number line to these numbers, or to these endpoints, and then I subtract them. For segment AB, I'm just going to start at 5 centimeters. And I see that B goes to 22 centimeters. So the length of segment AB is just going to be 22 minus 5, or 17. Remember here, segment AB would be AB with a segment over it, but if it does not have any shape above those 2 points, then it's going to literally read length of segment AB, and it's now a number. If you put a shape above AB, it's a shape. If you don't, it's a number. And this is where I can use the equal sign. Same thing for both length of segment CD and length of segment EF. And at this point, all I'm going to do is measure them. I am going to start at 0 for the next 2, but I won't have to. 15 centimeters. Please note that if there is a dot at the end, you actually go to the middle of the dot for the measurement, because the dot only represents the point, and the point's at the exact middle of a dot. If there isn't a dot, you would start directly at the end of your segment. Next is the segment addition postulate. Mr. H, you think you have an answer? The segment addition postulate means you can add 2 segments together to get another? Yes, it is basically just a way to say that 2 segments that form a larger segment can be added together to make the larger segment's length. So for instance, if length of segment AB was 5 and length of segment BC was 10, length of segment AC would be 5 plus 10, 15. Example 2. Use the segment addition postulate to find the length of segment BC. When I look at the first part of example 2, I notice that segment BC goes from here to here, and there's no number labeling its length above. There is a number labeling the length of segment AB, and there is number labeling the length of segment AC. Now I know from the last postulate that the two segments add together to be larger. 20 plus blank has to be 56. Length of segment AB plus length of segment BC equals length of segment AC is the segment addition postulate. It's technically what allows me to do the next part. We should really put it first in every problem that I do, just so that way you get the idea that this is the basis of doing this problem. Plug in the numbers I know, so I know the length of segment AB and I know the length of segment AC. I can plug those numbers in instead of using a symbol. And now I just solve for length of segment BC. Yes, this problem was just as easy as taking 56 minus 20. But the idea here is that two smaller segments' lengths add up to be a larger segment's length. Down here, same thing, I'm looking for segment BC. In this case, the segment addition postulate will give me this. Segment BA, the length of segment BA, plus the length of segment AC have to be the total length of segment BC. Yes, the letters have been changed around, but that doesn't change the idea of the segment addition postulate. So, in here, I know a few of the lengths, I'm going to plug them in. Length of segment BA is 25, length of segment AC is 35, length of segment BC is X. However, I look back, I'm looking for length of segment BC. I could put X in, but it's going to be an extra step I don't need. I'm just going to leave it as equals length of segment BC. And now I just solve for length of segment BC. And that's how you would do it for a problem like this. The next thing we need to talk about is congruence. So far what we've done is we've set numbers equal to numbers. In your entire math career, that's what we've done. No problem using an equal sign. Equal signs are for numbers. However, this thing called congruence is when we compare shapes. If I have a segment that's the same length as another segment, well, if I knew their length, I could set those equal to each other and show that way that they are the same. But what we try to do, when we know it's the same shape and same size, even if we don't know its length, we want to be able to say that they are the same. Instead of using equal, we're going to use this thing called congruence. What it basically means is that two shapes are the same size and are the same shape. Its symbol is going to look very similar to equal, but it's going to have a tilde above the equal sign. In this up here on your screen, you see length of segment AB equals length of segment BC. Let me write it for you. Let's say I have this. Length of segment AB is equal to length of segment BC. That means they're the same length, and they're both segments because that's how they are labeled. Length of segment AB and length of segment BC are equal. Therefore, they are congruent. Another way that I could write this, but be talking about shapes, would be to rewrite this with the segments above the AB and the BC, and the tilde above the equal sign. This one here reads, segment AB is congruent to segment BC. It's a little bit less of a mouthful, plus it still gets across the message. If I know these two segments are congruent, I know they have the same length. Please note, if you use congruent for numbers, it will be wrong. If you use equals for shapes, it will be wrong. The only time we can say something is congruent if it is actually something that has a size. We can't do this for lines because they are infinite in length, and because it needs to be same shape and same size. Well, you might say infinite is the same as infinite, but there is actually a deep mathematical proofs that infinity is not always the same size. So even though lines are technically infinite, and they're both infinite, we can't say they're congruent. Same thing with rays, because they don't end. It has to be something that has a finite, or a definite, or a length that we could measure, or a size that we could measure. So therefore, segment is the only shape so far that we've talked about that can be congruent. In example 3, they want you to plot these 4 points in a coordinate plane. I'm not even going to see what else they want right now. I'm just going to plot them. So J is -2, 5. So I will go -2 on the X, and then I'll go up 5 for the Y. So this is where J is. I expect you to write both the coordinate and the letter. However, for me, it's a little bit difficult. Just because I'm using a mouse, you can use a pencil. This takes me a lot longer. So there's J. Next will be K, 1, 5. So 1 is right here, 5 is all the way up here. This is where K will be located, right where the 2 cross. Remember, the first coordinate is the X coordinate, so 1, 5, the Y coordinate. The next thing they want me to plot is L is 3, 4. Therefore, 3 over, 4 up is right here. And the last one, 3, -1. So 3, -1 right here. Alright, now to read the rest of the problem. Then determine whether segment JK and segment LM are congruent. So I am going to draw a segment. Again, please excuse me for the... It's supposed to be straight even if it doesn't look straight. Sorry, it's just the equipment I am using. Because these are entirely horizontal or entirely vertical, I can just count up the number of boxes that it goes over. It's as if I assigned here -2 on my ruler, and it's as if I assigned 1 on my ruler. Because they both have the same y coordinate, it's just going to be straight across. The only thing that's changed is the x number line. So from -2 to 1, 1 minus -2 is 3. So this length is 3. Same thing for the vertical one. The x coordinate's the same, so it's just as if I used the y-axis as my ruler. One coordinate's 4, the other is -1. I could do -1 minus 4. -1 minus 4, you should get -5. But remember, length is always positive, so even though I got -5, it will be positive 5. 3 and 5 are not the same length. Therefore, length of segment JK is not equal to the length of segment LM. So my conclusion is not congruent. At this point, you should know what postulate 1 and postulate 2 allows you to do. It allows you to measure lengths with the ruler, and it also allows you to add 2 smaller lengths to be a larger length. Remember, postulates cannot be proved. You just have to accept them. And you should understand the difference between congruent and equal. Equal, only used for numbers. Congruent, only used for shapes. Right now, that is only the segments. Have a good day.